Geometry class, welcome. Today I have this topic, Pythagorean Inequality Theorem. Our problem for the day is the sides of a triangle have lengths 6, 7, and 7. What kind of triangle is it? Alright, before let me explain the concept that we needed to know before to try to solve this kind of problem. If, for instance, if we have, in this case, A, B, and C are the side of a triangle and then we have A less or equals than B, and then less or equals than C. Then look at this. We have this is very important ideas. This is the first one. Then A squared, okay, plus B squared is greater than C squared. If you have this formula like this, if only if, all right, if only if the triangle is acute, right? Very important concept. All right. The second one, three main ideas. If you have A to the second power plus B to the second power, but now equals C squared, then if, only if the triangle is right. Is right. Okay. The third one, when you have A squared plus B squared less than C squared, less than C squared, if only if the triangle is obtuse. Obtuse. So acute, right, and obtuse. This is the main point. The way it helps to us to find the answer our problem here. In this case, we have the sides of the triangle have legs 6, 7, and 7. What kind of triangle is it? All right. Let's start it. Keep in your mind these main points. Main concept. Actually, it's the definition of the class for today. First step here. All right. First, we have to put the three side legs in order. Here, put, all right, the three sides lengths in order from smaller from smallest to largest, from smallest to largest. All right. So let's start it here. We have in this case we have A equals 6, right? And then we have B equals 7, and C equals 7. All right. So from smaller to largest. In this case, we have this information in this way. So now to classify the triangle, so now to classify compare. So we have to compare here. We have our variables a squared plus b squared. Remember, compare to c squared. Right? We have to compare. So now we have the numbers. Here, write the numbers here. In this case, a is 6 to the second power plus b to the second power. So we have to compare right there to c to the, in this case, write the number 7. 6, 7, and 7 to the square. Alright. So now simplify here. We have 6 times 6 is 36. Plus 7 times 7 is 49, or 7 to the second power. And then we don't know here. It's 749. 49 right there. You simplify here, you're going to have 85 here. 70. So 85 here. Yeah, right. 85 is going to be graded to 49. Right. So look at here. Our conclusion, 85 is greater than 49. So remember the formulas, the little clue I gave it to you before. So now, since it's like a conclusion, some conclusion, since 6 to the second power plus 7 to the second power greater than 7 to the second power. So these are the sides. So the side legs. The side legs of an what kind of triangle? So an acute. Alright, this is the answer for our problem here. Remember, just check back my class in my video, and then you see why is a acute triangle. Alright, so but let me do another problem here. Let's change the numbers right there, right here. Change this number and give it different numbers right here. Let's write some different legs. Let's for instance 3, and let's write 4 and 5. Okay, let's see what happened here. 5. So first step that I told you. So the first step here, first put the 3 legs, 3 sides, leg, in order from smaller to largest. Alright, that's the first step. So our first step, then let's write it right here. A is equals 3, B equals 4, and C equals 5. Alright, that's it. Now to classify the triangle, so now to classify the triangle, compare. So what? Compare a squared plus b squared to c squared. We have to compare to this. So now we will have, give me the numbers right now. So it's the first one is 3 to the second power plus 4 to the second power. We don't know here, you compare is greater, equals, or less to the 5 to the second power, right? Just solve it or simplify. 3 times 3 is 9, and 16 right here. 4 to the second power is 16, and then 5 to the second power is 25. Out of this is 25. 25. The conclusion, 25 equals 25. Right there. So since here, conclusion, since 3 to the second power plus 4 to the second power equals to 5 to the second power, these are the side legs of what kind of triangle? Okay, when you have the equals, the triangle is one right triangle. Alright? This is a Pythagorean Inequality Theorem. This is the way to work. It's a Pythagorean Theorem, Inequality Theorem. Okay, I remember you. You discover the power of the mathematics, unleash your infinity potential.